Welcome back so we can wrap up our third section of 5-2. So we're going to continue to develop this idea of writing a polynomial from its zeros. Okay, so I first want to do a quick review of what we talked about in our last notes. So in our last notes, we developed the idea that we can take the zeros to reconstruct their factors. So a 2 would come from a factor of x minus 2. A negative 2 would come from a factor of x plus 2. And a negative 5 would come from a factor of x plus 5. So again, just working on the idea that we can use zeros to reconstruct the polynomial. And if we want it in standard form, remember that just meant foiling a couple times, right? So here when I FOIL these two together, that gives me x squared plus 2x minus 2x minus 4. And the neat thing in this instance is 2x minus 2x and all that means is now we have this, so it means we can FOIL it one more time to get it in fully standard form. So here that gives us x cubed plus 5x squared minus 4x minus 20. Okay, so just FOIL it a couple times to get it completely in standard form, and there we go. Now, today we're going to develop this idea into something a little bit more complicated because obviously we don't always get nice roots, right? Sometimes the roots are nasty, okay? And there's two things I mean by nasty. You can get roots that are square roots, or you can get roots that are imaginary, that you can't even physically see, okay? So when you have a root, so talking about radicals, let's say something like square root of 5. What this theorem is saying is you automatically know that you have its opposite as well, okay? And by opposite, I'm talking about its conjugate, which is something you've seen before. You heard that term back in chapter 4. You're actually going to hear that term again, flash forward into chapter 6. So this conjugate idea is something that is not going away. Conjugate meaning opposite, okay? Same thing with imaginary solutions. So here if I have an imaginary solution of 7i, well, I'm also going to have negative 7i, okay? They always come in pairs, okay? These square roots and these imaginary solutions, again, always come in pairs. That is the big idea of today. So, really quick, let's just run through looking at these solutions right here, 3 and square root of 2. And it says write an additional root that you need. Well, I know I'm also going to need negative square root of 2. Okay, I need its conjugate. I'm going to need negative 5i. And here, this conjugate would be 1 plus square root of 3, okay? The only thing that flips is the radical or imaginary piece. If it's a complex number, you just flip that sign, but the real piece or the rational piece stays the same, okay? So that's what we're looking at. We're looking at, can you identify what additional root you need, and then can you actually just do the same thing as you did yesterday? All right, so let's take a look at that. So write a polynomial with rational coefficients in standard form, given the following zeros. Your hint, first use the conjugate root theorem to identify the additional root that you need. All right, so for this first one, I see 0 and square root of 5. Well, what that automatically means is negative square root of 5 is also a root here. Okay, that's the first thing I would recognize. Now I can set it up. Okay, now that I have my roots, now I can look at rewriting the factors. Well, if I have a 0, remember the factor that made that is actually just x. If I have a square root of 5, the factor that made that is x minus square root of 5. If I have a factor of negative square root of 5, the factor that made that is x plus the square root of 5. So once I have all my zeros, I can write out the factors that they make. All right? And once I have that, now again, standard form implies I need to FOIL this out to get what I want. Okay, so I'm going to start by foiling those together. So we're going to leave the x alone for now, and let's FOIL what we've got. X and x, of course, make x squared. Square roots of 5x, negative square roots of 5x. Square root of 5 and square root of 5 would be square root of 25. That would just give me the 5 back. Okay? And one of them was negative, so obviously the negative there. Now, a neat thing will actually always happen when you go through this process because you have that the positive and negative here. Those will actually always cancel out. The middles will always cancel. So here what I'm left with is x squared minus 5 there. This time I don't need to FOIL. This time I can just distribute in that. And there is my polynomial. All right, so notice by recognizing I needed that additional root, it actually made my original polynomial very nice looking. Okay, so that's the goal of today, is getting good at this process. All right, so looking at our next one, because I see that 2i there, that also communicates to me that I need negative 2y. So first, always recognize, do I need an additional solution? Do I need an additional root? Once you do, now you can go through and you can make all of the factors. All right, once you make the factors, now be smart about how you FOIL them out. So here, I'm going to select these two as the two that I'm going to FOIL out. All right. So let's FOIL those. X squared plus 2ix minus 2ix. Now there, you're going to get a minus 4i squared. Okay, we're going to talk about that in just a moment, that negative 4i squared. Now, the neat thing that always happens is notice that inside piece cancels. 2ix minus 2ix, boom, done. So now I have x squared, and now let's focus a little bit on this, okay? Because remember from chapter 4 that I squared is negative 1. Okay, remember that back in the end of chapter 4? So I squared is negative 1. So negative 4i squared would actually just be a positive 4. Okay, so as long as you recognize that, well, now actually all we need to do, foil again. Okay, I see two binomials multiplying, so this tells me if I FOIL it one more time, then I'll be able to get to my answer. So that's going to give me x cubed minus x squared plus 4x minus 4. All of those have different powers, so none of them are like terms, and so that means that I'm done. Okay, there's my polynomial. All right. So let's look at the next one. So again, the idea being that we need to identify the additional root. So here I see a negative square root of 7. So that means positive square root of 7 must also be a root. And now that I have all of my roots, now I just write out my factors. Okay, so there are my three factors. And now I'm going to cleverly FOIL them together. Okay, I'm going to start with those two. So I have x squared. Now I'm hoping that you're recognizing by now that here x square roots of 7 minus x square roots of 7, I'm hoping that you're recognizing that those are always going to cancel in this process. Okay, so I'm not even going to write them out because I know they're going to cancel those two inner terms. So the last thing that I'm going to worry about is square root of 7 and negative square root of 7. Multiply those together, you get negative square root of 49, which you would know as negative 7. Okay, so you can actually save yourself some work. If you recognize that those insides are always going to cancel, you don't have to write them out. Okay, so here notice I just jumped straight down to this, but it's still not standard form yet. So what that's telling me is I'm going to have to factor this again. X cubed plus 3x squared minus 7x minus 21. And there you have it. All right. And this next one. So here I want you to recognize you actually need two additional things. You need the negative square root of 2 and you need the negative 3i. Okay, you actually need both of those additional solutions. So make sure that you are aware of that. Sometimes you need more than one additional zero. Okay, and now I'm just going to take a little bit of time. I'm going to write out all of my factors. So once you have all of your solutions, then you want to write out all of your factors. Okay. And now here you have a lot going on, but I'm going to be very clever in how I factor. I'm going to factor these two together first. All right. When I go to do that, I get x squared. Now again, here's where you can be clever, okay? So you don't get so much writing. So here notice, x square roots of 2 minus x square roots of 2, that is going to cancel off anyway. So I wouldn't even bother writing down all that extra work. That's just going to cancel out. Ignore them and focus on this last foiling connection. Square root of 2 times negative square root of 2, so you'll have negative square root of 4, while negative square root of 4 is just minus 2. Okay? And so once you have that, now let's focus on this. All right, so let's focus on foiling this. So I get x squared. Now again, be smart. 3ix minus 3ix, those innards are going to cancel. So don't feel the need to always show those inner pieces when you know ultimately they're going to cancel. Just focus more on that final connection, negative 9I squared. Okay? Now, remember, you do have to be careful with that I squared because I squared, remember, is actually negative 1. So really what you have is that. Okay? That's really what you've got. And so now, if you notice, again, you're not quite in standard form yet. However, you can FOIL this out one more time. X squared times x squared gets you all the way up x to the 4 plus 9x squared minus 2x squared minus 18. This time I do see like terms that can combine, and so I get all the way down to here. All right. And again, just make sure you know the shortcuts because that will help you. Don't write out all the things that are going to cancel anyway, because you're just going to get bogged down on little details and miss kind of the big picture that's going on. All right. So here is kind of a challenge problem. Okay. So challenge problem, this is above what I would consider putting on the test, okay? But it is something that at college level math, they are going to show you. So if you take college algebra, pre-calc, anything like that, you are going to see problems like this. So I do think it's worth exposing you to. So here I see an additional root that I need. So the additional root this time is that, okay? And that is what's going to make this a little bit messier, okay? Because before, we only had like 3i or square root of 5 or something like that. Here, we have the whole thing, okay? 1 plus square root of 2, 1 minus square root of 2. So this gets a little bit more complicated when you go to write this out, okay? Because when you go to write the factors, the first one is just an x. But when you go to write the factors, now this time you have x minus 1 plus square root of 2 and x minus 1 minus square root of 2. So notice that this is just a little bit messier to have to work with, right? So how can I do this? So what I'm going to do is, of course, you're going to have to FOIL that out, all right? So y equals, I'm going to have that x out front. And now let's FOIL this out. So I have x and x. Now, here's what's kind of mind-blowing about this. I have x and that. Oops. I have this and x. And then I have these two whole things being multiplied together. Both have those negatives out front, so it is going to become adding. But we get this whole mess here. And this is why this is a much more complicated problem, okay? One that I deem way above the test is because you have this whole mess that you still have to clear out. Okay, and how do you clear it out? Well, let's continue focusing on the parenthesis. Now I have to distribute that negative x. I have to distribute that negative x. And now, above everything else that I just did, I have to FOIL this out. Now, because those are all just numbers, I'm actually going to make this a little bit easier on myself because on the calculator, my calculator can actually help me with this. So because that last thing I have to FOIL out, again, is simply numbers, I'm actually going to let my calculator do that work for me. Show me that that whole mess clears out to just be -1, okay? Again, just to simplify my life a little bit, in the process of all of this, that's throughout this. Now, some things I want you to notice. X square root of 2 minus x square root of 2, just like that. We have minus x, which is a minus 2x. And now finally, let's distribute that x. So I have x cubed minus 2x squared minus x. So just showing you that this is possible to do even when you have the whole conjugate you have to deal with, not just the radical piece, not just the imaginary piece. But again, for my test, don't worry about this, okay? If you understand the previous slide, you are going to be absolutely golden for my test, okay? But I do think this is a good opportunity to let's talk about all the things that I've been making you do, okay? Because obviously that's the goal here, is building up to our ultimate test. So degree, naming this by degree. Degree 3 is going to make it a cubic. Number of terms, 1, 2, 3 terms, is a trinomial. End behavior, that's where I analyze. The degree is odd and it's positive. So think of a line with a positive slope is going to start at the bottom and end up. And relative max and mins. So let's take a look at that. So relative max and mins, I'm going to go to graph this thing, x to the third minus 2x squared minus x, minus x graph. Oh, and that looks lovely. I have a max here, a min here. So let's really quickly just review those calculator skills. Because for maxes and mins, remember that is literally straight off of the calculator. So I'm calculating, so going to calc. I'm going to start with that max. I'm going to scroll till I'm left of it. Then scroll till I'm right of it. Hit enter. And there is my maximum. So negative 2.2 and 0.11. Negative 0.22, 0.11. Now let's go back, do the same for the minimum. So I go and calculate the minimum. So here I'm to the left of my minimum. Then I'm going to scroll until I'm to the right of the minimum. Hit enter. So here I'm at 1.55, 1.55, and negative 2.63. Don't forget, I'd like you to go to 2 decimal places, please, when you're rounding for maxes and mins. So, of course, very important, still know those calculator techniques to help you. So, thank you so much for joining for me. I know that this is a lot to take in with all these square roots and imaginary numbers. So, thank you for joining me. And please make sure to take a moment, write that summary, and then come back ready to do your practice work.